Hi friends, this is day 4 of doing Codeforces. So let's try to solve the problems 800 ranking problems of CP31 suite of TLE eliminators. And today it is target practice. So what is it? A 10 into 10 target is made out of 5 rings as shown in figure. Each ring has a different point value. The outermost ring 1 point, next ring 2 and next ring 3 up to 5. Okay. Valid fired several arrows at the target. Okay. Valid. So it's not, sorry, it's not a valid, it's a valid. I think it's a name. So help him determine how many points he got. Okay. So the input consists of multiple test cases. The first line of input contains a single integer, the number of test cases. Each test case consists of 10 rows. Each contains containing 10 characters. Each character in a grid is either X or dot. Okay, representing no arrow. And this X representing the arrow. Okay. So on this board, whenever there is an X, so that is where the arrow was shooted. And the dot, it represents the arrow wasn't shooted there. And output, so for the test case, output is single integer, the total number of points of the arrow of wild. Okay, I think for this 1, 2, 3, 4, 5, 6, 7. So it's not like 7 because we have to return its values, summation of the values. So like this is 5. I mean the outermost layer is 1. So 1 and 2 and here it is 3. 3 plus 3 which is equal to 6. So 6, 7, 8, 9 and 10, 11, 12, 13, 14, uh, 15, 16, 17, 18. Sorry. This, so 5, 4, 1, 2, 3, 4, 5. So this is 5, right? So we have to add only one fact. Okay. So, but here in this test case, all are valid, uh, all are uh, total. The area of the board have arrows, like total. How can I say that? Total part contains the arrows. Uh, so completely. So we have to add all these ones, twos, and threes, and fours, and fives because all are having arrows in this test case. So we get output as 220. Okay. So here this 3 is the score and into 1. There are only one value at 3 and there is only two value. Oh, how can I say? First test case 3 into 1. 1, 2, 3. So 3 has only one value. 1, 2, 3. Okay. And 2 into 3. So that means 1, 2, 3. 3. Okay. Actually, 3s are 2 and 1s are 2. So 1s are 2 and 3s are 2s. 2s are 4. So here 1, 2, 3, 4. 1 and 1, 2, 3, 4, 2. So two fours are there and one only one five is exist. So like that we have to count it that way and we have to return its final value. And here as there is no x value, it represents the score is 0. Okay, it's I think it's easy we have, but we have to make the arrow board. What is it? C plus plus online compiler of CodeChef. as you can use your own compiler. So it's common. We have to read the test cases. So entity, and then we have to run on the test cases. We also have to make the scoreboard, and it's not better to make each scoreboard of every test case. So we have to make the scoreboard on the outside of the while loop. So how the scoreboard is look like? It's look like matrix. So a matrix, and it's like integers from 1, 2, 3, 5 rings with the different values. He didn't mention the length of this bird. Each test case consists of 10 cases. No, no, no. Must be represent that, right? So 10 into 10 target is made out of firings. 10 into 10 target. So there are 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 into 10. So what is it? It's a like vector of vector. So then only vector of vector is nothing but a two-dimensional array, right? So score, like SB, it's represents the score. Okay. Now uh, we can so like maybe we can write it here, so it's gonna be more clear way. So the size, the vector size is a 10 into 10, and the outermost score is actually 1. So 1, 1, 1. So I think it is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it is 10. 3, 6, 9, 10. Okay. And now it is 1, 2, 2, 2, 2, 2, 2. Our total size is 10, right? So 3, 4, 5. So now we have to write 5 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But here the values are not these 3. And right, yeah, here it is 3. And wait, let's go back. Here it is 2. But it is 3 here. 3, 3, 3, 3, 3, 3. So okay, enough. So 3, 3, 3, 3, 3. Okay. So 3 outs. So 3, 3, 3. Okay, all threes now after 3. So the inner scoreboard is like 4, 4, 4. Oh, sorry. Here it is 3, 4, 4, 4, and here it is also 4, 4, 4, 4, and 4. And it is 5, 5, 5, 5. At last, we made our code, and it's a vector board, right? So there is no need to declare its a size before. We don't need to use this vector. We can also use array. Like we already know how to initialize the two-dimensional array in C++. It is int of SB represents the scoreboard, and your each total size is 10 into 10. So because there are 10 rows and 10 columns, so these represents 10 rows, and this represents 10 columns. Boom, that's enough, right? So like check. Okay, here it is not one, not two. Here it is one. Oh, thanks. So one, one, one. One, one. Okay, one, two, three, four, five. Yes, right. One, two, three, four, five. Okay. So now we have the scoreboard. After the scoreboard, so now we have to take the data from the where the arrow was shooted. So we want to know that, right? For that test case, the scores are different. So for each test case, there is a separate score. That's why score is equal to 0. Okay. Now we have to take how many times we have to read the data from the user. So of course, it's must be 10 times, 10 into 10 times actually, because each row is of size 10. So as we have to read data right up to the end of the matrix from the user, so we have to write two for loops. So for the outer for loops actually tells the rows from where we are presenting on the row, and inner for loop tells where we are presenting on the column. Also from 0 to less than 10 and I++. It's not mandatory to take 0. Oh, I'm sorry. It is mandatory to take 0 because array initializations are start from 0 in C++ programming language. It's not for C++, it is for Java and Python also. And it is also 10 and yeah. So for each test case, what we are doing, we have to read data from the user, right? So before that, we have to declare a character. So let's say it is C, and now we are reading data from the user. Okay, so and we have to check if that character is actually X. So is it capital X or small x? Let's go and check it. Okay, I'm pretty sure it is not a small x, so it is a capital X. So whenever it is capital X, what we have to do? We have to increase our score from the scoreboard. So how can we locate the scoreboard value? Yes, it's related to the I and jth value. So it's actually scoreboard of I. Yes, yes, you got it right. Scoreboard of I and score j. So this is what suppose for 0 and 1th, I'm shooting an arrow at 0 and 1th position. So this 0 and 1th position is represents this. So now the value is 1. So that one is added to my score. And at last, so after for loop, we have to print our answer for each test case. So now it is a score and ended. So let's run on this test cases. Mhm. 1705 2020 1705 2020. Yes, same. Besides, here the term complexity is acceptable. Here total test cases are 1,000, and time limit per test case is actually 1 second. So 1 second, it can capable of performing 10 to the power of 8 operations. How can I say? It can perform 10 to the power of 8 instructions in 1 second. Uh, and here it is only test cases constraint is actually 10 to the power of 3. Let's say 1,000 is actually 10 to the power of 3, and 10 to the power of 3 square of it is actually equal to 10 to the power of 6. 10 to the power of 6 is actually less than 10 to the power of 10. So yes, is time complexity is okay for it. Let's try to submit this. You are not allowed to view the requested X page. Didn't I? Okay. First, we have to log in into the Codeforces to submit the codes. Okay, now we can submit using namespace. But before that, we have to it's slash std c plus plus dot h. So it's slash std standard c plus plus dot h. You have to include that library. Let's see. Come on, come on, come on, come on, and it's accepted. Cool. Let's go to the another problem. So which is ambitious kid. Okay? So ambitious kid. Chanika. Chanika and Park Chanika's child is an ambitious kid. So Park Chanika, Park Chanika, Chanika, Park Chanika's child. Okay, Chanaka is a child of Park Chanaka, who is an ambitious kid. So Park Chanaka gives her the given problem to test her ambitious. Okay, given an array of integers. In one operation, Chanaka can choose one element, then increase or decrease the element by one, and Chanaka can do that operation multiple times for even for different elements. Okay, not only for that same chosen element, he can also perform on different elements. So, what is the minimum number of operations that must be done to make it such that A1 into A2 into A3 into actually equal to 0? Okay, it's a cool thing, right? So we already know that whenever the multiplication result is shown, if it contains value 0, then it will become entire result is 0, right? So, like, so for this test case, here there are it doesn't contains a lot of test cases. So for each test case, you have to read a single integer n, and which represents the size of the array, and we have to read the array from the user, and we have to output a minimum number of operations that must be done to make it equal to 0. So we actually want to put to make any element of an array. equal to 0. As we want minimum number of operations, we have to choose the closest number near to uh, near to 0, but not actually 0. If contains 0, then we can perform, like we don't need to perform the operation. In that way, the result becomes 0. So see here, for the test case, he clearly mentioned that. So as the array contains already 0, now the total product of the elements in the array is actually 0. So 0 into minus 1 into 0 into 1 into 0 is actually 0. So we don't need to perform any operation, increment or decrement operation by 1. So we don't need to perform. So we have to return 0. So for minus 3, so in order to make it as 0, even it contains one element which is not equal to 0, we have to return, we have to multiply. So as we want result 0, so we have to turn minus 3 into 0. In how many operations? In 3 operations. Because in first operation, we can add plus 1. Now it becomes minus 2. In second operation, we can add another plus 1. It becomes minus 1. We can add another plus 1. Now it becomes 0. So for 3 operations, it will become 0. So, okay, whenever the array size is 1, okay, we can directly return that, like that, that element value, but in positive way. So for this 2, 6, 5, the closest value near to 0 is actually 2. So we have to return that value only. So what we are actually done here, we have to try to find, iterate over the array and try to find the minimum value. If the minimum value is exist, so we have to return that number of operations. This is the minimum value, and here this is the minimum value. So okay, we have to return. Okay, I think you got the intuition already. So let's try to pull a clear for. So we have to take a value n from the user and see. So for each m, what we are doing, I'm sorry, it doesn't contain any test cases, right? So we just build an array of size n. Why don't we need to print a vector? Let me show the power of STL, standard template library, right? So I can say that vector is A and which has a size n. So at first we are iterate over the iterate over the size of the vector in order to extract elements for the vector, right? So C and A from I. Okay, so now we are actually uh, having an array of size n. Now we have to iterate over the vector again in order to find the closest value near to 0. It's the closest value near to 0 is nothing but the minimum value. And let me say it is the answer which we have to return. Initially, there is no need to initially. What it contains? It contains the minimum. It needs to contain the minimum value, and we can compare it. Okay, it's like finding minimum in an array. So let me say, it's first initializes to a of 0, and it's thought, okay, this is the minimum value. Okay, now we don't know whether it is minimum value or not, so we have to iterate from 1 to the remaining size of the array. We have to start from the 1 because we are initializing the 0th index. We thought the at 0th index we have our answer, right? So now if array of I is actually less than answer, then we should change the answer is equal to array of I. Okay, simple. That's enough. And we have to print that answer. Yes, as there are no testicles, we just put a semicolon. So let's try to run. So as 2 is the okay, I think here minus 6. As I thought, as I thought, um, this minus 6 is actually uh, is a negative number, and we need a positive number which is close to 0. Minus 2 is the smallest number, but we need a number which is close to 0. So close to 0. mm, we can add a test case like before changing it, uh, we can say a of I must be greater than 0. So if you run, okay, it is satisfied. It must be satisfied too, as it contains only one element. So it returns minus. We are actually initializing it with minus 3. So minus 3 is our answer. So we just perform the closest. Okay. So there is a confusion with the test case too. Uh, our code actually finds the minimum value, which is minimum value among the given elements, and it isn't that value. We actually thought that is the answer for the value answer, and here minus 3 is not the answer. Absolute of minus 3 is the answer. So, absolute ABS is an inbuilt function which actually print the result in always greater than 0 form. And let us take a test cases like it contains a size 4, it contains completely negative values like minus 1, no, not minus 1, minus 3, minus 1, minus 2, and let's say it is 1. So now what is our answer? Our answer is actually 1. Here it is 3. Why it is 3? Because it is initialized. This is actually initialized. We initially thought this is an answer, and we have to iterate from here to here. And if that element is actually minus 1, it represents that uh, it's a negative number. So and we have a of I must be greater than 0. So minus 1 is not greater than 0. Minus 2 is also not greater than 0. But 1 is greater than 0. And 1 is actually less than answer. Answer. 1 is less than minus 3. Minus 3 is the smallest value. Okay, before initializing, we have to keep it as this. So then the answer is 1. Yeah, even that answer is 3. Why? I less than size n of 0. Here the time complexity. We can simply sort the array and we can return that first element. But we even that we have the negative element. So we have to but its time complexity is big of n log n. And here as it must be 1 second, it must not contains big of n log n time complexity. It won't accept it. Think about it. All we have to find the number which is closest to n. and either from negative side or from positive side, right? Um, from negative side, okay, three is the answer. Uh, let's make it. Okay. What if we can minus 3 is the answer? It initially thought it. So answer is equal to 3 as we are pushing that 3 into right. So now the answer is equal to 3. Okay. We can run again on the arrays. Now the answer is actually 3. So, and find whether okay. We all we have to do just perform the operation again. While performing the operation again, we have answer initializer to, and we have to start from one. Why we need to perform? So okay, consider this is just not a part of code. Let's understand this. So before take, we have to use ABS function, right? Then we got one right. So one less than three, and we have to okay. Let's try to run this code. Even though it is three. I got one idea. So all we have to do just print the number which is closest to zero. So it always must be positive number, not the negative number. So from this to this, from one size to n. So AI. So we have sure. So we have to take element and that element has to be a positive element. So that's why I'm applying ABS function to that element. And if that element is less than answer, okay, less than answer, there is no need to use this sign here. Okay, less than answer, then only answer is updated to that element. Okay, so let's try to use this code. Yes, we did it. We did it, bro. Mm, come on, two. Okay, let's try to submit it. Not right. Alright. We can submit this code. Let's submit this code. I'm bad in English. That's not a problem. Accepted. Close all. Solution. Yes, it is accepted. Good. Let's go to the other another one. Sequence game. So Tima and Vicky are playing the following game. I think it's belong to the game. And see here, it's time per test is actually 2 seconds. Okay. Uh, first, Vicky comes up with a sequence of positive integers a of length n and write it down on a piece of paper. Then she takes a new piece of paper and write down the sequence b according to the following rule. First, she write down a1. A1 is actually an integer from the first set. Let's and she writes down only those AI so such that I less than or equal to m size and I has to start from size 2 not from 1 such that ai minus 1 actually less than or equal to ai. Okay, so we have to find the uh, same elements in a sequence, and not same elements less than or equal to same elements in a sequence. Then we can take that element and we can write down. She write down AI. So after completing the AI, so in order to write sequence P, she write down AI such that AI I minus 1 is actually less than A1. Let the length of the sequence be denoted as N. Okay, that sequence length is N. For example, in this sequence 4 3 2 6 3 3. So uh, whose size is actually M. This size is actually M. And 3 plus 3 6. Okay, M is equal to 6 here. And Vicky will obtain the sequence B. 4 6 3. So whose length is 3. So how 4 6 3 actually present in B? Let's 4 uh, 6 and 3 and in the end, as 3 is less than 2, start. I minus 1 is actually less than or equal to AI, but 4 AI. Maybe we need to swap, even if we need to swap, uh, we shouldn't able to include the element value 6. So let's say she then gives the piece of paper with the sequence B to Tema. He in turns tries to guess a sequence of A. Okay. From this, he tries to find a sequence of A. Tima considers winning in such a game highly unlikely. So Tima's winning is highly unlikely because she has to exactly predict the elements which are presenting in A, right? So with this just B sequence, but still wants to find at least one sequence here that could have been originally chosen by Vicky. Help him to Vika. So it's not Vika. So whatever it is, just a name. So help him and output in such a sequence. So each test case, multiple test cases, which are less than 10 to the power of 4. Okay, 10,000. The first line of each test case contains a single integer, the length of sequence B. The second line of each test case contains n integers, the sequence P integers. Okay, we need to know the sequence of, we know already the sequence, the size of B and the sequences elements which are presenting in B. So that is what represents here. And as it is 10 to the power of 9, we can simply use the integrated adapter. And sum of the values of n overall test cases does not exceed 2 into 10 to the power of 5. Okay, it must be inside this range. For each test case, output to two lines. In first line, output is single integer m. The length of the sequence. Okay, we have to represent the length of the sequence. And in the second line, output m integers, so which are nothing but array eighth element integers. I think you already understand this question. uh, 3 4 6 5, and the output is array size is 6, and with elements of 4 3 2 6 3 3. Okay, but how? For 5 1 2 2 1 1, and here it is a 6 1 2 2 1 1. So the first sample is explained in the problem. In the second one, Vika could have chosen the original sequence. So 1 2 3 1 2 3. So for this 1 2 3 1 2 3, why the uh, answer is the same as the test case B? Why the A answer is same as because it satisfies the property, right? One less than and two and two less than three. And here for this, so four less than six, four less than six. But here it is not 6 less than 3. No, there must be something which is present inside this array that we didn't understand. So first Vika comes up with a sequence of positive integers a of length m and write it down on a piece of paper. Then she takes a new piece of paper and write down the sequence p according to the following rule. She write down ai. She write down ai first. According to the following rule, she write down ai first. Then she write down only those ai. So from a1. So she actually write down A1. So from those A1, she write down those A1. So starts from element 2, from 0, from element 2 less than or equal to M. So A2, A3, A4. So in that way. So A2, A3, A4. Such that A I minus 1 is actually less than yeah. As the length of the sequence is denoted by N. Okay. Let's there is something definitely we are missing here. Something. What is? What is it? What is it that I am missing here? OBS. Okay, it's still recording. Let's read the question again. Tema and Vika are playing the football game. I mean, sorry, following game. What is that game? So Vika comes up with a sequence of positive integers a of length m. So he has a sequence whose length is m, and he first write it down on the paper, so whatever it is. So then she takes a new piece of paper and write down the sequence b according to the following rule. So she write down a new sequence from that following rule. That rule is actually she first write ai. So she actually write the ai. So she already have the a sequence, right? So first sequence whose length is m. From that, he take the first element, AI, and then from the second element, he chooses the element such that it is actually 1. Okay, so such that AI minus 1 is actually less than or equal to AI, such that whenever the AI is greater than or equal to the AI minus 1, we have to write that AI element into our current element. So in this way, we have to build a sequence of B and return that. Is it working? So for this sequence here, the sequence B is actual. Okay, what we have is actually a sequence B. From this sequence B, we have to sequence A. So for 4, okay, uh, 4. First we have to take the element of a 4. Yeah, because it is a A1. So we are reading the A1 element. So 4, 4. After that, we have 6. This 6 is greater than 4. Yes, of course. 6 is greater than 4. Why we need take 6? Because 3 is not greater than 4 and 2 is not greater than 4. But 6 is greater than 4. That's why we directly take 6. And here 3 is greater than 6. No, but 3 is greater than or equal to 3. So that's why we have 3 here. In that way, B array is formed. Okay, I think you got the approach, but we have to do in a reverse way so that we can get the array A and its size, right? So the only possible testing system is 2 whenever uh, the current element is greater than that element, we have directly print the and store that element. And whenever it is not equal to that, we have to store the minimum of 4 and 6. Like in 9 is greater than 7, 9 is 5 is greater than 9. So 5 is not actually greater than 9. So in that time, we have to choose the minimum of 9 and 5. So 5. So 5 is the minimum. So that's why we are choosing 5 there. And along with that, the minimum element 5 and current element is actually 5. So 5, 5. We can we can get that one also. So 1793 instead of that 57. We can get a structure like 179557, right? So let's code it up. Then if you code it up and check whether it is right or wrong, you can go further on. So for each test case, we have to take what we have to take. We have to take the size of m and vector of int. So first one is a sequence of a whose length is actually m. And okay, so we have to read elements for a sequence. I mean, for B sequence, what we have is a B sequence, right? So let's say, let me call it as B sequence. Okay. Now we have to read element of a B sequence. Boom, right? So after taking the element, our approaches are only to, our conditions are only two. But before that, we have to visualize a vector which shows the answer, but it doesn't have size. We don't know its a size. Okay, so but we have to iterate over the known vector size, which is here is okay. Cool. So now we have to check. Initially, we thought we have to take a dot. We have to take the first element of b of 0 as the first element in our sequence also. So that's why we have to push b of 0 element, and from 1, what we have to do, we have to check whether uh, b of I is greater than or equal to also okay I minus 1. So we directly push back that b of I element. That's what we observe. Else we have to push back two elements. So what are the, one is b of I, but this is after minimum of b of I, comma, and b of I minus 1. So now we have the array A. So throughout, we have to find the size of an array. So int array size equal to a dot size. So now we have to print that size. So after that, we have to print each element inside the array A. Okay, so see out each element with some gap. Okay, good. Let's try to run on this test case. I really don't have hope in this. Min of okay. It's just a syntax error. We have to use the correct syntax here. Okay. Uh, I get the runtime error. And the size error. Yeah. Okay. This is true. And here. Okay. Okay. I get the runtime error. Why I get the runtime error? And less than. And then you loop with less than n. Think about it. Why I'm getting the runtime error? There must be some wrong here. Yeah. Um, yeah, I have treated over the size M. That is it. We didn't read the M. That's why we get it. We have to read the M, size of M. Then only we can able to read the size of each. Take the elements from M. So 4633 like and 142 2 1 144. Okay. It's better to write after completion of this. We have to go to the next line, right? Let's check this. Okay, now for 114, as it is only one element, so that is the element. We write and two for 211. Yes, 211, 114, 121. Yes, 12311. Yes, I get that thought from this approach. So as 2 is greater than 1, 2 is greater than 1, we have to put, and 2 is greater than or equal to 1, we have to put, and 1 is greater than or equal to 2. No, it's not. So then we have to put the minimum element of it and also that element. Then only here two ones are there. Now, when we go to the second one, it actually less than or equal to its previous element. So we directly print that. Okay. But here, for the first ashes, I only get 4633, which is just a possible sequence of 4326 double three. It's not exactly equal to 633. That is why I'm hesitated to submit this code. But whatever, the remaining are test cases are passed. And here in this code, there isn't any line that telling me there exist a more possible sequences. You can only return any one of them. Wait. Note that the length of the sequence you output should not exceed the input size. So it won't exceed the input size by more than two times. So by more than two times, it won't exceed the input size. So input size is 3 and 4, 5. So 1, 2, 3, 4, 5, 6. Here he gets 6, but I'm getting not exist more than 6 times. I have some like after reading that line, I know uh, my code must be accepted. It should be accepted because there are so many possible ways. For but for the first test case, it's accepted. What we need to check whether our generated array is actually two times more than the previous array. Hashtag include bits slash std c plus plus dot h. Then submit. So I have already Accepted. No, no, no. Okay, it is accepted. So that is what the problem with these games. In games, there are multiple number of ways. We should return any one of them, not all, not the exact accurate one. So in this games type of question, we didn't blindly use the test cases. We have to read the question carefully and understanding it, and then only after we can write the code. Okay. So this is just an amazing question, and it's already fine. So we will solve this problem on tomorrow. Okay. Thank you for watching this video.